from learn about mixed mixed numbers. That's I mean numbers. Who wins? Want to play? Sure. Another in another.
Okay, so he's telling us about fractions. We see that as they're counting up the number line, we go from 1/4, 2/4 to 3/4. All of these are like regular fractions. We're pretty used to them. But once we reach 4/4, like he's saying, calling that a whole fraction. The reason why it's a whole fraction is because the numerator and the denominator are both the same number. So 1/3 would be another example, Messiah. The only reason why they're using fourths is because they cut this into 4 pieces. See how it takes 4 of the orange blocks to match the blue block? So that's why this is fourths. Once they get 4, they have 4/4. They have one whole. What he's going to show us right now and what we're going to be talking about this week is going to be what we call an improper fraction. Improper fractions don't look like regular fractions. And an improper fraction, I'll show you right here in the video. Like you said, it doesn't matter what fraction you're talking about. Anytime that you have a numerator and a denominator that are equal, you have a whole fraction. Nakai, turn your camera off, please. So whatever your denominator is, if your numerator is the same, you have a whole fraction. 2 out of 2, 8 out of 8, 100 out of 100, whatever it might be.
See, now we have fraction.
So an improper fraction is when the numerator, the top number, is bigger than the denominator. Normally in a fraction, your denominator, the bottom number, is always bigger. But in an improper fraction, it's the opposite. That's why we call it improper. Like saying it's not right. 5 out of 4 would be an improper fraction because the 5 is bigger than the 4. That's also why when we talk about fractions, I don't normally say the big number or the small number. I might say the top number or the bottom number, or the numerator or the denominator, but because of improper fractions, we can't always say which number is bigger and which one is smaller. It depends on the fraction.
Numerator.
So this is an important thing. Sometimes when you get to improper fractions, like the example they gave us here, 5 out of 4, some people don't like to write improper fractions. They prefer mixed numbers. The reason we call them mixed numbers is because it's a mix of a whole number and a fraction. Now, we worked with these this last week when we were talking about changing decimals to fractions. But we need to see, or we need to be able to change one of these mixed numbers to an improper fraction, or to go the other way. Like he said here, 5/4. If I look at it this way, it's the exact same thing as 1 whole and 1/4. We can see that they reach the same spot on the number line. So I could write my fraction like this. I could make an improper fraction, 5 out of 4. Or I could write my fraction like this, 1 whole and 1 out of 4.
Whole fraction. Mixed numbers. Whole fraction. Proper fraction.
So just like this last week, we were making sure that our fraction and our decimals were equal. This week, we're still working with fractions, but instead of changing a fraction to a decimal, we're looking at two different kinds of fractions. A mixed number, which is a fraction mixed with whole numbers. The improper fraction, where we have a bigger numerator than the denominator.
Thirds. Group of mixed number 4.
So we can see here that mixed numbers don't just have to have a 1 in the front. You can have more than one whole. Here, with the improper fraction 8/3, you actually have 2 wholes. You have 1, 2, 3, and another group 1, 2, 3. And then you still have a little bit more beyond that. In fact, you almost have enough to make 3 whole groups. Since we don't have enough to finish this last whole group, that last part stays as a fraction. 1 whole group, 2 whole groups, plus 2 out of 3 pieces of the next group.
Pretty cool. Number. Usually shown. 2 and 2. Over 3.
Right now, he's just showing us how we're able to make those groups of 3. We have 3 pieces of 3. We have another 3 pieces. Then we have 2 pieces extra. 1 whole out of 3, plus another whole, another 3 out of 3, plus our leftover, 2 out of 3. If I were to ignore my denominators here and just look at the numerators, 3 plus 3 give me 6. 6 plus 2 would give me 8. Exactly what I had at the beginning. 8 out of 3.
Numerator. Original.
So he's showing us one way here. I'm going to be showing you a different way. I think it works a little bit better, but this is still a way that you could change between mixed number and proper fraction. Something else I want to point out to you all. Look at your denominators. Look at this first example. My denominator was 8. It never changes. Whether I have an improper fraction, whether I have a mixed number, my denominator is 8. It stays an 8. Same thing here with this example. My denominator is a 5. It stays a 5. Never changes. Whether I have an improper fraction or a mixed number. Or in this last example, my denominator is a 3, and it will stay a 3. Whether I have an improper fraction or a mixed number. Like I've told you before, your denominator is the most important number in your fraction. It does not change. It will stay the same. So this is a little closer to the method I'm going to show you all how to use, but it'll be something similar to this. We'll be using some multiplication. but it's not exactly the way that he's doing it here. We do ours a little bit differently. So he's showing us this method, and just like the other one, there's a slightly different way that I'm going to be showing you all, but this is another way to do it. And like you said, when we're subtracting one whole at a time, you need to be careful that when you get your answer, whatever is left, that you don't have mixed number that has a larger numerator. Like here he had 5 out of 2. Here he has 3 out of 2. So if you end up with something like this, you know that you're not finished yet. There's still more whole numbers that you could have subtracted out.
Two over two. 2 over 2. Whole number.
So here, now that he has this answer, he can tell that what he has is, like he said, proper form. There's no more holes that he could subtract out of here because there's only one piece left. He's not a. You can see that the numerator is smaller than his denominator.
Whole fractions.
So he's using division right here, Jadine. The one that I'm going to show you is a little bit different. It's not exactly the same, but what he's telling us is when we have an improper fraction, 7 out of 2. If we want to change it to a mixed number, we need to see how many whole numbers are in there. We know that 7 is larger than 2. So we know that there's at least one whole number like hiding here, basically. So he says, okay, what if we take away one whole? 2 pieces. We have 5 left. But 5 is still more than 2. So there's more pieces I can take out. Now he's saying, okay, we took away 2. Let's take away 2 more. So we're taking away 4 pieces. We do that, there's 3 pieces left. 3 pieces is still more than 2. So I can take away even another set of 2. Take away 2, another 2, and another 2. There's only one piece left. So finally, we can see that the numerator is smaller than my denominator, and we are able to take out one group of two, two groups of two, and three groups of two. But like I said, the way he's doing it right now, I can show you kind of a similar way to do it, but with the other, I have another way that I'm going to be showing you this week, how to change from an improper fraction to a mixed number, that I think is a little bit simpler. But I'll show you more examples using that different method this week. We are going to practice more.
Improper fraction. Writing top number, bottom number.
The answer isn't bigger, it's actually equal to. Like he said, when you have an improper fraction, like 7 out of 2, your numerator is the bigger number. You have more pieces than you need, because you only need 2 pieces to make a whole, right? Out of 2 pieces, like a Kit Kat bar. When you get the little Kit Kat bars, it's 2 pieces, right? So if we have 7 of those little Kit Kat pieces, we have way more than just one Kit Kat. What he's trying to do here is figure out how many whole Kit Kats does he have. So every 2 pieces, he's got one whole Kit Kat. You'd have 2 pieces, that's one whole. 2 more pieces, another whole. Let me show you what his answer was. I can explain to you. So 2 pieces, that's one whole Kit Kat. 2 more pieces, that's 2 whole Kit Kats. 2 more pieces, that's 3 whole Kit Kats. And then he's got 1 more piece, but he doesn't have enough to make another whole. So he would have 3 whole Kit Kats plus 1 piece out of the 2 pieces he would need. So that's why it looks bigger, but it's actually equal. It's the same thing. Alexa, make sure we have our camera off, okay?
Numerator.
So he's kind of doing the same thing here, except now instead of out of 2 pieces, our denominator is 5. So now he's making groups of 5. So he's counting by 5s. 5, 10, 15, 20. He was able to make 4 whole groups of those 5, but he's going to have a little bit extra. So he had 4 whole groups of 5s, plus he had 2 extra for the next group of 5.
Sign. You really?
So if it doesn't entirely make sense or it's still kind of confusing, don't worry, because like he said, we're going to practice this week. We're going to see more examples on how to do this, and we're going to work on it some more. So we'll get practice. We'll get a chance to kind of figure it out this week.
Doing it right. Always. See you next time.